Our speaker this evening has over 22 years of industry experience. Please welcome the Senior Solutions Architect for Hazelcast, Joe Sherwin.
Thank you. 22 years, huh? I stopped counting. Welcome. Today, we're going to be talking about some of the trends in data. How many people have positions related to data in their organizations? Go ahead, tell me what you're doing back there.
I do reporting with Power BI.
So you do reporting, so business analytics, right?
Sort of.
Yeah.
On the back end side.
Back end, okay. Anyone else?
Like reporting and dashboards in R, specifically working with QuickBooks.
Okay, interesting. So using MapR?
No.
Did you say R or
Yeah, R. Like,
just regular R?
Yeah.
Okay. So using R to calculate the analytics, okay. Anyone else?
IoT data, we have two different approaches. We're doing SQL and doing Postgres with timescale DB for time series.
All right, time series, interesting. Okay, so.
I just have a question, Joe.
Yeah.
I'm John Capello. I drive Joe around.
That's my driver.
How many here are work in financial services? So, few.
Yeah. So yeah, you can see that from our audience here, we have a lot of people where data is very important to them. But I'm going to ask a question to the group, and the question is, whatever happened to big data? Anyone dealing with big data? What does big data mean to you?
slow data.
Thank you.
Big
Because
data,
that is
slow
exactly
data. Good answer.
that is exactly where we're going with this presentation here. Is talking about what is the next step. Big data was all the rage a couple of years ago, and again now we're looking at data swamps, right? And slow data retrieval, slow computation on data, and all the other problems related to big data. And some of that has to do with batch data processing, right? So processing data overnight, running your big data job overnight and waiting for the results. So is batch processing end of life? So does anyone think it's basically the end for batch processing? And how business? You don't think so? Can you tell me why?
Oh, mainframe still exists.
The mainframe still exists.
Global still exists.
Mm-hmm.
That's the page.
Wow.
Global DB2 is
Write this down, John. We have a lot of opportunities.
Well, we still have insurance, we have hospitals, we have large banking institutions. Mainframe is not going anywhere. I mean, they try number of projects with a client server, even Merrill Lynch, number of projects, at least 4, and they scrap them all.
Right. Yeah. That's horrible. So everything you just said, it keeps me busy. It's what I do. It's what I did today. Is discuss with customers what are we going to do with all this data you have in IMS. Okay, and how do we stream that data from IMS into a distributed services and using that data for analytical processing.
We still have, besides IMS, we still have IT.
IT, yeah, IGMS.
Non-relational and relational.
So, yeah, so there's that. To us in our industry, that represents a lot of opportunities, and those are the type of problems we're trying to solve. Is how to make all that data more useful, how to have more successful projects that try to make use of that data. So there's a lot of fails there in the past that we're trying to improve. So yeah, batch processing is not necessarily going to go away. It just has to be done faster. Okay? So this is what the big data landscape looks like. Anybody recognize something they're using at work here? Yeah. How much does that cost you? Yeah. Who's doing the BI reports? What are you using on it? Are you using SAP as well, or IBM? No, Cognos.
No,
Okay. Sorry, I left you out of this slide.
There is a Oracle over there, there is Informatica.
Informatica, yeah. Yeah, so all of this is the stuff that Hadoop is somewhere in here. The data warehousing, data lakes, Teradata. I spent $8 million at MassMutual on it, Teradata.
Or any data.
Or any data warehouse, and then having a DR failover solution for that as well. So you can see why big data has lost its momentum. You can see why it was stopped in its tracks. Not only that it's slow and hard to deal with such massive data, it's very expensive infrastructure. So let's start our discussion. Really, what we're here to talk about is what's happening now in our industry. So 75% of organizations are considering data from IoT sources as a high priority and critical item for them. Nearly 90% require data to be ingested, analyzed in a day. Financial companies, they don't do that in time, they incur some serious fees. Okay, so this processing of data, ingesting of data, getting the results from your analytical, your reports, affects the bottom line of most businesses. So if you're working in that space, you're very important to your organization. 73% are using or planning to use machine learning, AI. Anybody using machine learning in their processing? You're reading all this data. Are you learning anything from it? It's just a report, right? It just shows up on the desk of whoever's using it or presenting that day. Or maybe it's a quarterly thing. But,
It's a beginning of the journey.
exactly.
Perfect.
Yeah.
Not even close.
Not even close. But what we see there is opportunity, right? Yeah. And both for us as career individuals in the space, and us as software developers, solution developers, what we have here is opportunity. So what's happening now is the new space in data processing is stream processing, okay? Being able to process that data, even the data that's sitting there in our data warehouse, how do we stream it to an application? How do we get the data out on the fly and do calculations as the data is coming in? Versus what we've been doing in the past is batch processing and stale data. So we all familiar with the old school pattern. We collect data, maybe it's from an online operational data store that we're lifting and loading and dropping into a data warehouse. We process that data. Huge latency, meaning it could take hours to create that report. So when we look at the use cases, when you talk about batch processing, usually you're doing a post-mortem analysis of that data. What happened last quarter? Hopefully that will be relevant to this quarter. The tools we use to do that, Hadoop, Hive for SQL people, and often a lot of custom tools. Sometimes we can take that data that's sitting there and we can run it through some kind of machine learning algorithm. Data scientists, again, when big data was hot, the other hot role was a data scientist, right? Everyone needed a data scientist. So the data scientist struggled a lot to bring value to an organization, by the way. So integrating that role of data scientist into that big data swamp environment was quite a fail for a lot of organizations, because they did not have the infrastructure and tools to immediately bring value to the companies, their employers. So offline transaction processing, ETL, transformed. We do a lot of we spend a lot of money doing ETLs. You know, sometimes I joke to people that my job is really I'm just a data plumber. I'm just laying data pipes. But so let's now look at what's really trending and how we're looking at data and today, and what the opportunities are to really bring value. So when we talk about stream processing, what are we talking about? So first thing you have to understand is that real-world data doesn't come in batches, right? So what is real-world data? Anytime you click something on your app, it's an event. Anytime someone buys something from Amazon, it's an event. It's data that's being generated at a real-world activity. Anyone buys a stock, that's a real-world activity by a financial organization. Okay, so that data is not coming in batches, it's actually coming in streams. Okay? So that's what we call stream processing. Right? So you're quite familiar in how we deal with data that's at rest in a relational database, for example. So SQL, it's quite familiar to all of us. This is a SQL New York group, right? So, so those types of tools, and we need tools now and methodologies and APIs that can deal with data that's streaming. The other concept I'd like people to also think about is that if I went into an order database or an order table in a database, it's a collection of orders. And if I decide to order those collection by date and stream it, it's a collection that is a time series of data, isn't it? So it's also can be a stream. So you can take data that's sitting there and make it a stream. I usually try to compare that to a CD player. Anyone remember CDs? They're like these round things. Yeah. So that's data at rest. When you put it in to a CD player and it starts spinning, that's a stream of data that your analog to digital chips are actually doing calculations on and turning that digital data into analog that comes out your speaker, right? So that's data streaming. Okay. So continuous processing, continuous use. Okay, so now there are the challenges. Low latency, continuous programming model, understanding how to define event times, event windows, not ingest time. Event time, again, if I have a timestamp on my record in my orders database, that's the event time, not the event that it comes into my system. So what are the tools? You'll see out there, if you're out there looking for a job as well, or interested in finding solutions for your organizations. We have Spark. Has anyone heard of Spark? Anyone using Spark? Uh-oh. Good. We have Flink. Anyone heard of Flink? Yeah. Okay. Kafka Streams. You must be hearing that a lot around the office. And finally, our company has what we call Hazelcast Jet. Okay? So those are the new tools in the streaming world of data. So this is a conceptual, logical picture of what really happens. I don't care which tool you're using, but typically what you have on the left is a source of data, That data might be streaming and it might be batch. So it might be that record, the order table that I'm streaming to my stream processing engine. So in essence, this is a batch job, but you're treating a batch as a finite stream. Okay? But you can use the streaming API to also process batch data. So it's not going away. It's just getting faster. So typically what we do to that data is we, of course, ingest it. We might combine it with something else, enrichment. We might aggregate data. I want to find out what's the average stock price in a 30-second window all the time and make a buy decision or sell decision. And then we sync that. We call it a sync in Hazelcast parlance. We call it the endpoint where we publish to as sync. So we have sources and sync. And typically that's what you'll see. Okay? Now, when I'm using Hazelcast, I have the ability to talk to many different types of sources and also many different types of syncs. Questions on this picture? Is anyone doing anything like this? A little animation here. So, every organization has a collection of data sources currently. One of the things that we do, the traditional things we do is that we create a data warehouse and we say, I have all these sources of data. It would be nice if I had it all in one place. Why? Why not just get the source from the source and combine it with all the other sources of data? Create a quicker, a much more valuable solution immediately. ROI on these big data appliances, technologies that become slow because you're waiting to upload the entire day's operational database overnight and then run the job. That's not going to work anymore for the fast-paced world. So any source of data, this allows you to talk to warehouses or operational data, combine them, so I can actually join multiple sources of data, multiple streams, and do my data processing on that data in real time. Now, I say real time, so as I'm streaming or iterating through the data, I'm computing it. Now, what I write over here, it may not go directly to a UI that a human is looking at. It may go to a report like we normally do now. It may go to another RDBMS where some other app connect to and view that data immediately. But that data is continually changing and up to date for whoever the decision maker is. And those are called our data sets. Okay. And what you'll see in any of these streaming APIs, that they usually call these things connectors. Okay. So how does it do that? Like I said before, typically what it does, if you're talking to HDFS, if you're talking to Oracle, Kafka, it basically takes the data coming in as a stream. Usually, again, it's the event timestamp they're going through in an ordered manner. If you're doing a real-time data stream, it's usually you have to have some kind of windowing processing. So we allow you to define the window, and maybe you can do an aggregation within that window. If you're doing a batch, you're obviously going to take the entire stream and maybe do an aggregation or something like that. Question? Go ahead.
Question. What are blockchains?
Blockchain. Well, blockchain it's interesting that you say that. Well, so blockchain, right? So blockchain processing or transaction processing, it's not necessarily fit in here, but what we do when it comes to blockchain is that we can actually take stream of transactions, if that's what you want to do. If you want to do, if you want to basically aggregate the, what the performance is of a Bitcoin or something like that. If you want to store in memory certain attributes about the market, you can store it in market, and you can actually enrich the data as it's coming in. So, as far as blockchain, nothing very specific to blockchains, but we do enhance certain processes on top of the transactions that do blockchain. Because again, this for our solution, we'll talk specific. I'm talking in general right now, but later I'll talk specifically about the Hazelcast API. And something special about the Hazelcast API that really speeds up blockchain processing is that it's in memory. Okay. So all these streams and things like that are in memory. So transform data when it's moving, extracting analytical workloads, not RPC, data from warehouses. That's basically what data processing pipelines are all about. That's what we call this particular flow. It's a pipeline. I'm not sure if everyone uses this term, but that's exactly what we call it. Any questions?
Question about MQ series.
Go ahead.
Is it similar?
Yeah. Yeah, MQ, Kafka, messaging, they're all pretty much similar. You have different native APIs and the native codes you need to connect to those guys. But yeah, again, it's like JDBC, JMS, same kind of thing. Yeah. So so now we kind of understand where the data processing industry is going. We understand the fail of big data, promise, and batch processing. Now the question is, next generation data processing is how do we mine value out of these data sources? How do we create apps that actually work, that do not fail? These things are very difficult. That's the reason why a lot of them failed early. Because dealing with that amount of data, size of data, volume, or the velocity of the data was a big issue for early technologies. So mining value out of streams, okay? So the concept here is understanding what's valuable about having all this data, whether it's streaming or in some big data warehouse somewhere. How can we help our organizations get to the value of that data? So there's this concept of the diminishing value of data. Okay? And no disrespect to people who spend their lives doing code to spit out reports, monthly reports, big giant spreadsheets. But as your data gets older, it becomes less valuable. Okay? And that's very important. So the high value data is in this time span here. Okay? These time critical decisions, if you're doing applications that are in this range of latencies, these are the high value. But this is where traditional batch sits in. So if you're doing BI jobs for the past 10 years of our company performance, someone's going to see that, I don't know, 2 days from now. That data may not be as valuable to a company anymore. Because again, we know the market's changing. Every company is digital transformation. You hear that a lot. Have to make decisions quickly, have to be more nimble. So now, the data that's important, the time frame for that data is diminishing. Time critical decisions. I took an Uber here. And I was trying to explain this to my Uber driver. I tried to explain to him the time he decides to drive is critical to maximize his profit and his time driving. So there's a high value time for almost every activity that you're doing. Okay? So the inverse of that is so analytics, right? Analytic value escalator. We're calling this a Gartner. So if you're doing anything in this range here, prescriptive, how can we make it happen kind of decisions, what will happen, predictive, why did it happen, and then if you're looking in the past, what happened, okay? So there are some big data workloads here that actually is quite valuable in some use cases. But also there's also a time perspective to this, right? So even what happens, if you can do that faster, it's more valuable. So here, let's think of one right now. So if I have video footage of a crime that just happened, if I can analyze all those video footage and identify the perpetrators on that video faster, okay? So they can get on a plane and go to Brussels or Mexico, wherever. So just being able to process that data faster, quicker, it's much more valuable to the organization you're working for. Okay? So even the what happened, if you're looking in the past, the value of that is actually increased if you can actually do it faster. Diagnostic analytics, what's happening now, those kinds of dashboarding use cases, those are very valuable to your organization. Okay? So you can see now, as you get to the more higher value analytic use cases, the difficulty of doing those kinds of applications increases. And this is where you are with this very large mainframe, getting MIPS off the mainframe and stop doing it in batch. That's why it's attractive to try. It's difficult to do. Okay? So getting that foresight quicker, that increases the value. So you gotta say, wait, if I'm working in this data space, where am I on this escalator? Right? And then you can get an idea of how important your job is to the organization. So typically, analytics and decision making. Here's some of the use cases again: real-time dashboards, stats, gaming. I don't know if anyone is a gamer here, but you do online gaming and you see the stats of everyone else. That's latency is very important for gamers. Infrastructure monitoring. What's going on in my network? How many users are connected to my database? I want to know that in real time. I can get alerts, make decisions, recommendations, predictions. You're clicking. I know you've been clicking this particular product and doing a search. Now I can push real-time suggestions to you. Okay. The other thing that's very interesting too is now if you have multiple streams of events and you can find a correlation between those two events, now you can do complex processing, right? So that's now in the realm of possibilities, right? So what we have is a collection of tools and technologies now that you may have heard of that are being used from finance, IoT, oil drilling, retail, all these different market verticals to really get the value of data and really make all that data collection that companies are doing worthwhile. So, is everyone familiar with these technologies? We've heard Kafka before, some of you. Okay. Well, Kafka is a messaging infrastructure. Kafka can be used so application communication, events, broadcast. So it's lightweight, message broker, very huge. And that's the other thing you'll see now is that a lot of technologies that started out as one thing are now adding streaming to their capability. So even database manufacturers are adding a streaming API. Kafka has a streaming API now. Apache Storm, Spark, they're all open source stream processing. Some of these are available in the cloud as well. And so the emergence of stream data, IoT data, and cloud, there's kind of symbiotic, and there's some challenges as well in doing these kinds of workloads in the cloud. So these software solution manufacturers, have to provide cloud services. Some cloud services, Amazon, AWS, they've gone so far as to take these open source technologies and provide you with a managed service that you can use in your application to actually stream data to and do your calculations and things like that. But what we've done at Hazelcast is we've replaced all these different technologies that do specific things differently with Jet. Right? And that's what we'll talk about. How does Jet actually allow you to do all these things, connect, stream the data, compute the data at scale, and write to sinks or publish to sinks as well, all in one API. Complex event processing, again, to do those, get insight, this happened and this happened, those type of scenarios, that must mean that something else is likely. Those gleaming meaningful patterns out of your data streams. Again, very difficult to do before. Really had to get a ninja team of developers, data scientists as well, to really understand how to do that. But now, with the Hazelcast Jet product, what we're allowing you to do is to use that one Hazelcast Jet engine to be able to apply all of those technologies into one scalable solution. So the common type of analysis that we see now in data, again, time and location-based windows, within, near, based in real-time context, what's happening. I want to find a moving average, a 30-second moving average of transactions on the market, aggregations, grouping, and aggregating, accumulating a variety of quantities, sum, averages, min, max, linear trend analysis, those kinds of things. Event relationships, again, we talked about that with complex events. Event A followed by event B, event A and B, okay, and the non-event. So, so before looking at all these things and being able to do this was quite a computer science challenge. So now we have these APIs that are making you, enabling you to create apps like this very simply. So we talked about big data being dead and the end of batch processing, but as we know, there's still data out there in Data Lake. It's not going to go away, or in your mainframe. So being able to access that data, being able to pull that data out, whether it's a batch data set, so HDFS, for example, data warehouse, for example, or it's a streaming data set. Crunch the data, return a graph or a report, whether that query is live, so meaning that in the streaming use case, your dashboard is continually updated, your report is actually active and in real time, or making decisions off of that. Any questions on that?
My question was, if you remember, about 10 years ago, Reuters messaging platform, I forgot the first word, second was impromptu. What was the first one? Doesn't matter. Anyway, you probably know what I'm talking about. So what's happening with that one?
Yeah, I have no idea. So I have no idea. So
What you know about this?
yeah, we work with a couple of such companies. Bloomberg is one of those companies that actually the business is really based on and analyzing message and data streams. So being able to do that quicker, it's more scalable in the cloud, making the programming less difficult. Those are the things we're tackling with this API. Those are the type of applications you're going to see more. Those are the valuable applications to your organization. So a lot of the traditional way of looking at data is basically changing, and some of the tools are changing as well. And that's basically what we're talking about here. Is how are they changing? How can we use them? How can we tool up and get on the bandwagon? So let's look at some solutions, right? So this is a logical example of a solution that's using data to do predictive analysis and decision-making platform. JPML, anyone familiar with that, the machine learning engine? Okay. So you can train your models, and there's bunch of different tools to train a machine learning model. You can turn that machine learning model into a JPML. Use that JPML against as your data is streaming into the streaming engine, and basically report analytics, decisions, alerts to who's ever listening, whether it's a user, actual person, or another connected system, a website. It wants to automatically give that user click a suggestion, things like that. So this is typically the kind of use case we see, especially when we start doing ML and AI integrated with the stream processor. Any questions? Yeah, so, and again, service integration, microservices, we wrap these things in microservices. Even the engine itself can be a Kubernetes service or cluster. We also have an in-memory data grid where you can actually write, like I said before, write the results of your scoring or your predictive analysis, so that retrieving that data is really fast through any other connected system or UI that's out there. So the other one is churn indicator. A lot of people are interested in churning and predicting customer churn. Am I going to lose? Comcast is wondering if they're going to lose you as a customer. So being able to do that in real time and bringing that ML type of decision. So the key here, right, I failed to mention is that this is not new. What is new is the ability to scale it with this engine. So it's a big box here, but it can go to infinite number of nodes. It can elastically scale up and down if you're running in a Kubernetes environment. The data, the way we're actually doing the stream processing, is called a directed acyclical graph. So it's going one way. And that way of representing analytic work allows us to scale the different vertices and pipe the data to different processors at different nodes, different threads within nodes, and really scale the compute capability up so that the data, the answer is quicker, the volume and of data, the speed of the data coming in is not an issue. We're able to handle the velocity of your data. 100 million messages per second is not a problem for a 4-node cluster of Hazelcast Jet. So that's what really changes the game here, is that this is done in memory. There's no disk you have to go search and get all the data from and then do some math on. It's done in memory as the data is coming in. It's scalable, partitioned automatically. You don't have to know about that when you're writing your job. You just have to know how to write a pipeline process. And a pipeline process, as you'll see, is basically saying, here's the business steps to do. Go do it. Here's the data source. Here's who I want you to write it to. Here's the business steps to do. Whether it's first group them by something, then apply something. Maybe it's a linear trend. Maybe it's a calculation for CO2 emissions. And then spit that result set out to a sink. Okay? So some of the things you might include in this particular example is the calculation, the analytic calculation of the machine learning algorithm for doing that would be injected in your steps of your process. Okay. So that being said, any questions on that, guys? Okay. So I'm actually going to skip to this guy. How are we doing on time? Okay. So we talked about it at a high level. So this is where the rubber meets the road. So the question is, we have a data lake somewhere, and the data is streaming. As you know now, people are referring to some data lakes as data swamp. The biggest data swamp in the world so far now is Twitter, maybe Instagram as well. So how do I make use of that data in the Twitterverse? Well, fortunately, Twitter allows you to register as a developer, use an API key to read the tweets of every one of their users. That's great, I can do that. But how do I know what they're saying? Right? Oh, this is where the data scientist comes in. There's someone at Stanford who's written a natural language processor for English. And they can tell me whether or not there's a negative or a positive sentiment in that sentence, group of sentence that's coming out of Twitter. Okay? And you say, well, okay, I'm into Bitcoins. What are they saying about Bitcoins on Twitter? Okay, so I have a group of coins that I'm interested in. What's the sentiment about these coins? So this is what this particular demo is really doing. So it's demonstrating how to go against one of the largest data sets that's out there that's actually being tweeted in real time, how to apply some AI algorithm to that data stream, and write the aggregator or result set of sentiments to an application. Okay? So we're going to take a look at that now. Anybody here use Twitter? Well, hopefully we don't see your tweets coming through. All right, let's see. Okay. All right, so I'm going to just kill a few things here and run that example. Okay. All right. I don't know if you guys saw when I was setting up, I was kind of testing it out. So you can see we're getting tweets from around the world, not just English, but so. So what's really happening here? Oh, Jesus, that I have an error. Okay, let's find out what error that is. Okay. Okay, we have a deserialization error. And fortunately, I'm familiar with what the problem with that is. There's a really odd thing about Lambda with Eclipse, when you compile with Eclipse, so that's what we're having here. So let's, we're going to rebuild using Maven, and get rid of that problem, and execute again. Okay. All right. So you can see my DAG job. It comes out graphically here. And you can see we're getting live tweets. We're going against live tweets in this case, not historical tweets. So what this job is doing is saying, okay, every tweet that comes through, I'm going to look for a set of coins, if they're mentioned in there, and I'm going to determine what the sentiment is about these instruments. And he's actually going to graph them. Let's make sure this is big and nice and big so you guys can see. This, so now you can get the number of mentions of the particular currency. Here's the little legend here that can tell you which currencies we're looking at: Bitcoin, Ether, EOS, Ripple. So you can see which one is much more popular on Twitter. And this is live data, by the way. And the sentiment, positive or negative, everything's negative right now, it seems. I don't know who's tweeting positively about Bitcoins. I'm sure there are some people doing it. But you can make some inference here if you're looking at this data, like, well, it seems like Bitcoin is obviously the most popular, right? If you didn't know that, you do now. The next popular one is Ether. Okay, all right. And okay, maybe it's, based on what you're looking at here. So these are different windows here. So this is a 30-second window. This is a 5-minute window. We've only been running a little while, but you can see the trend. And you can say, well, I'm not going to touch these guys. Yeah, so this is the kind of thing that we're able to do. And look at that jump right here. Wow. There we go. Now we get some action. The longer it runs, the more you can actually see more dynamically what's really happening on Twitter in terms of the discussions about these coin instruments. So, but the key here is a very simple application. But in the past, doing something like this is quite difficult. And we'll just take a quick look at what it requires in terms of programming. So, let's go here.
Sorry, is that just like a web on your?
Actually, it's SWT, Java. Yeah, good questions. So first, to understand what's actually happening, we have a little monitor tool that we attach to the engine, so we can actually look. So this is the Jet Management Center. You click on Jobs. We didn't give it a special name, so you can see what it's actually doing, the steps, and how the data is flowing in each step. That's the other thing you want to be able to see and monitor here. Let me just better view of this here. Can everyone? It's tough. Okay. Let's go. All right. Okay. So basically, again, the source is Twitter. He's pulling the source information. He's putting it in a flat map. You can hardly see it. He uses a map, what's called a map using context. He's filtering for the coins that we're interested in. Okay. Now he's doing two types of windows, the 30-second and the 5-minute windows. And he's basically, at that point, he's actually calling the natural language processor API, and then he's writing the results to an in-memory map. And actually what this app is doing, it's polling, it's actually listening to that in-memory map. So every time there's an event into the map, the key is obviously the name of the Bitcoin, and the sentiment score is the value. And this client app is just pulling that map and plotting the sentiment. Go ahead.
The steps that you apply, is that a no-code solution or is there a way to hold that?
Yes, so that's this. Yeah. So we write that with a pipeline API. So that's the magic that makes this stuff easy now for all of us. So let's look at the it's called a crypto analysis demo, and let's take a look at it. All right. So again, you can see it here. So we talk about what the pipeline is. So basically, let me see if I can get this better in terms of the resolution here. Okay. One more. Okay, so you'll see that this will happen. This happens basically in every pipeline job. So basically, you build a pipeline, right? You have a stream of coin values. Okay. So, and you have the Twitter source. So Twitter is a data source, right? In our case, we've written a custom source for this Twitter API. So the API allows you to build custom sources or use the built-in ones, the typical ones, Kafka, JVC, message, any type of JMS. We have S3 ones and things like that. But yeah, so the first thing you do is you draw from the source, right? With the native timestamps, of course. Then you get the tweets. Then you iterate through the tweets to get the sentiment score, the crypto analysis, sentiment analysis, flat map to relevant using context, the sentiment analyzer, Lambda here. Then he's doing an aggregate of all the sentiments that he gets, and then he's draining them to the map where the UI is actually listening to this map. So when you look at the analyzer, again, what we're using is the Stanford. The Stanford API, natural language processing API. So it's the Stanford Core Natural Language Processor API that we're actually using in this example here. The util. And one of the things we actually do is that we get a here we go. This is the console printer, but support. So we're using these corn types that we define here, and we're basically searching all the tweets for these coin types. The other interesting thing here is the fact that we use the Twitter API and create a custom data source. You can see my properties. Also, it will include my Twitter custom key and everything else as a developer. Get that. Get the JSON object. So Twitter is actually sending me a JSON object, which has the tweets in them, the tweet text in them. So it's actually, what's happening is it's continually filling a buffer of tweets and sending it to me. And so I'm creating a stream of data with that data source. Questions? And of course, we have the fancy little GUI that just listens to the map. Yeah. Go ahead.
So is that UI, is that running, or I guess is this running on your laptop, or is this streaming from somewhere else? Or how do you share that with your coworkers?
Right. So yeah, this is a little demo, but you can imagine it being a web app or something like that. You can imagine it being an app that says, you know what? Instead of these defined ones that I'm doing statically, you tell me which ones you're interested in, and I'll submit your job for you and send you the string, right? So that's why you can build on that in a real-world application.
So
Right?
I guess like essentially like your product is turning a model just into an API.
Yes. Yeah. So if you look in the, let's go back to the, okay. So if you go back into the actual, so when I build this pipeline, I'm using this coin values, these enums that I'm iterating through to actually filter out the tweets. So that job is specifically for those sets. If I wanted to do, if the user was in control of what sets, they would send me, maybe have a click, send me that set. I would create this job dynamically for them and start running it into the Jet engine. Now the Jet engine here, in this example, is actually, so here the engine is embedded, right? You have the option of doing it. So this is, again, it's not a cluster. It's just one instance that I'm starting within my code. So it's an embedded implementation. But technically, I could have sent that job, it's where I do Jet new job here, as a client to a Jet cluster and submit my job to the cluster. So yeah, this is just one job that's running and sending it to one client.
So,
But
so
yeah.
what do you say kind of is the business model?
Yeah. So, right. So, yeah. So you have to. So that we use our imagination and try to understand what other sources of data we have in our organization. Maybe to. This little example here doesn't mean much to you, but conceptually, we're all doing the same kind of things. We're getting data, we're streaming it, and we're trying to make decisions or get some idea of what's going on, okay? And typically, the difficult data to deal with is the data that's moving, that's streaming. So having a nice, simple way of being able to scale these type of processing. As you know, tweets are coming in worldwide. Your data set might be pretty large. The amount of messages per second, which is what I wanted to see here, get an example of how much messages is coming through. So we have a, I don't know if it's a network or not, but let's see what we're getting. Okay. We get a latency here, it's pretty high, actually. We're getting about 900, what's it, we got, 52,000 messages coming in since we've been running. So, again, as you can see, I can handle this amount with just a single node. If your system, wherever you're connected to, whether it's a Kafka stream or what it may be, or your database, CDC you're listening to, changes in your database, we can handle that. You just increase the number of nodes. So this process here, this graph you see here, is scalable. So the data that's getting piped to each step can be against multiple nodes. So we partition and scalable. In this particular case, I think we're doing a couple of filters which would partition the data across each node.
I want to say this is really cool demo.
Is it? I don't know, sometimes it's hit or miss.
On the Twitter side, what kind of latency is there?
Yeah, so that's the question.
100 million queries per second.
Yeah. Yeah.
How old is that data when you get it?
That's what we're looking at, the latency. So it's not only Twitter, it's your side too. The network here going through a Wi-Fi, that's also an issue. But yeah, that Twitter API better give you the data. It looks like it's pretty fast. The other thing you can look at is the timestamp of the actual tweets that's coming in. So there's a timestamp on the tweets. Okay, so that record, that JSON record, also has a timestamp. So we're actually using the timestamp on the tweet, not the timestamp the data comes in. Okay? So we may ingest it slower, but when we're doing our sentiment analysis, we're looking at the timestamp on the actual tweet record.
Plus, you're doing a Wi-Fi thing and remotely controlled. You're not,
Yeah.
This is not an optimal.
Right. It's not. And typically, if you're looking at market data at work, you have better networks, you have better connections. Whether your data provider is Reuters or Bloomberg, you have optimized connections to those things. So 100, like I said, 100 million messages per second is not a big deal. I think we've demonstrated we can do this with a minimum of 4 nodes.
One of the things that makes
8 CPUs per node.
quite unique is that in the engineering product, they use things like dream plays and other tricks to make sure that this thing is running at full capacity. The result is that we're about 15 times faster than any other stream processor that exists on the marketplace today. So combine that with a clustered environment, all running in memory, the data stores in memory. So we're running it, we're processing millions and millions of things in seconds.
All right. So now we're going to take another look at, we talked about some of these use cases. So we're going to take a look at a dashboarding use cases. Hopefully this one's not broken. This one's a little more involved from a flow process.
Are we doing on time, guys?
So this one's, so you can see here, there's about 9,000 aircrafts worldwide in the sky right now. So everywhere in the world, every aircraft that's in the sky that registered their flight path, maybe not the military ones with secret missions, we're getting from a data source.
Right now.
Right now, live, okay? And what we're doing in this particular case, we're saying, well, can you filter this one for all the aircrafts that are below 3,000 feet? Because I think they're either landing or they're taking off if they're at that level, okay? And I would like to calculate for these set of airports, what is the noise level, what is the CO2 emissions that's happening right now. Okay?
In real time.
In real time. Yeah. I saved the best for last, I hope. Let's get this going, hopefully. All right. So this is the live data.
You can't see this, so it's Frankfurt, London, Paris, Tokyo,
Atlanta, New York, and so the top is takeoff, the below is landing. If you see 0 for some of them, it's probably because the time of day the airport's closed. But basically, again, if we look at the let's look at the flow. So we go to the management center here. Let's refresh. Okay, let's go to jobs. This one actually has a name. All right. So, I don't know. Still, you can't see it very well.
That's the FAA data?
That's the FAA data. That's actually, yeah, so that's actually reported by different stations and people. Yeah. Okay. So basically, we go through the data source. The data's coming in as big JSON with 9,000 flights. We're actually filtering for all the aircrafts, again, at a low altitude. We're calculating the linear trends. So we're holding them in a time window and calculating the linear trends. And we said, I think this guy is increasing in altitude, so he might be taking off. I think this guy's decreasing in altitude, so he might be landing. Okay, so we put them in a landing map and a takeoff map. Okay. Now we say, okay, landing and takeoff. Now we say, okay, now I want to enrich this information for noise, because what I get with the aircraft data is the engine, the aircraft type, and I have a noise calculation algorithm that I can apply to that data as well. And also, I want to do that for CO2 emissions as well. Okay? And calculate that. And you know what I want to do is I want to send all that to an app, which is Grafana in my case. So we're actually syncing all these, not only the map, but to the Grafana sync. Question?
In the graph that you're showing, are all of those in different containers?
Now, when you say,
Yeah, for like each classification, not the map.
the acyclical graph, you mean? Oh yeah, so potentially, yeah, when you scale it out, so those can go to different instances of the node. So if I'm running a cluster, so you can see I'm running a cluster with a single node. So if I was running a cluster, yes. So that's how we scale out and get that
Parallelism.
we get the parallelism, but we get that latency in terms of calculating something that's really hard to do, right? So you don't even have to worry about it when you're coding it. It happens automatically. You just define the steps that you want to do in your business and your calculations. That's where the ease of doing something. You remember we talked about that scale of value, and as you go up that scale, it's very difficult to implement those solutions. That's where we get this ease of implementation. We can scale out automatically because we turn the problem into an object called a directed acyclical graph, and we just pipe the data to specific nodes and specific threads to do those calculation steps.
Where does the process data ultimately get landed typically?
Yeah, so in our case, the process data is going right to an application. So our sync, is what we're talking about, is an application, and basically I'm writing to a socket to the Grafana app that's running in a Docker instance. So this is actually a URL to Grafana running in a Docker.
It brings up a good point. We have another use case that we just did for a large investment bank where they have trades coming in and they're processing it today, stream processing it, but then they want to be able to kind of ad hoc decomposed aggregations, just kind of query inside. So they're taking the processing data and they're storing it to a database so they can query it. Well, it's kind of a complicated architecture, so because our product actually includes a in-memory data grid, you can do all of that in real time with one system. So you're processing and then you're querying, continuously querying it.
Remember the big picture, and this is going to be true whether using our product or any other product, is that you're grabbing data from one side, you're streaming it, processing it, and writing it to wherever you want to write it to. And typically, whatever you can read it from, you can end up writing it as well. One of the other use cases I have is that my data source is actually RFID scanner, right? Coming in, events come in, I want to do some calculations and aggregation on the RFID scans. With the scan, it comes, where did you get scanned at, right? So if I can track you, if you have the same RFID, I can see you enter this door, and you went there, and things like that. And I can track where your movement, or a package movement, a package with RFID on it, that gets scanned. I can track it through my whole process in real time, again. Okay? And then, that happens for companies like FedEx, UPS. They've gone to 7-day processing of data, of packages. So now they have to continually run these jobs all the time. And their packages are coming through the door. They get scanned as a whole truck, and they get put on a conveyor belt. And you have about 200 milliseconds to decide, does this package go to this chute, or does it go to the next one, right? So there's an automatic scanner that's going on and hitting something like this at the edge, right? And to make that decision for that package immediately. The first cutoff is 200 milliseconds because of how the belt is running, how the speed of the belt. So the distribution center has a low latency issue. And it also has an edge computing issue because you don't want to have to go all the way to the cloud or to some other data center to add latency to that problem.
So what's missing at Kafka, at Apache?
Yeah, so in our product, we actually have connectors for all of those well-known sources and sinks. So if you wanted to actually look at our product and see what we actually come with, and this keeps increasing.
It's not a replacement?
It's not a replacement necessarily for Kafka. It lets Kafka do what it's best at, which is messaging. So Kafka is usually, in most organizations, they already have Kafka and they're already using Kafka as messaging, or they already have MQ. So we just use it as a data source. The other way, let's say, if you have an IMS database and you're putting every transaction log activity onto IMS so that other people can consume it. So again, you can consume it here as well.
You still see IMS? Last time I touched IMS when it was at...
We're on a call today with a large bank who your debit card data is in this IMS thing.
Am I supposed to say that?
They need to make it happen faster. So they want real-time, they want us to real-time read it and then be able to give you a web-based app that you as a consumer can then see what's happening.
Last time I touched it when I was at Equitable.
Say again,
Last time I touched it when I was at Equitable. Right. But
They still
even no, well, it's an AXA, but it's no longer IMS. But even that time, DB2 was the most, and IMS was out of the ordinary, even that time. And it was 15 years ago, so it's still IMS, unbelievable.
Yeah,
And you're talking about replacing batch. It still didn't replace IMS, and they're talking about replacing batch.
Right. So what the cost of owning a mainframe is really the MIPS that they're getting charged for. So the MIPS is no longer on the mainframe. The mainframe is just it's a data swamp, data storage. So you want to move your data processing off of the mainframe. You have to push the data to your application level.
If you didn't mention, I would think it's no longer exists.
Yeah, we wish it didn't exist.
So you can see we have a library of different connectors, MongoDB, Redis connector, TCP sockets, and you can also build your own custom connectors. We give you an API for that as well. And then, for example, a FileWatcher, which is a typical one, where their files are being dropped to a volume somewhere, and you have to process it.
So we do things very, very fast, and now you enable new kind of class of applications that were unimaginable before.
Application log. So yeah, and again, some of these sources may be batch sources, and they may be streaming. And again, the API doesn't really look at it that way. If it's a batch source, it's a one file. It's just a collection that the API is streaming to the code.
When you're pointing about batch, what we're seeing is, while batch may have gone away, the window by which they want to process the batch
Yes.
is shrinking.
Yeah, and they're getting more files dropped, so it's becoming a real-time problem, even though it's really a batch problem.
Micro batches.
Security is not a problem.
Oh, security is always a problem.
We didn't mention it.
Yeah, we try not to mention it because we like to live in a happy world.
Right. But you mentioned batch.
There's security.
Yeah, so yeah, security is always a very big concern. I think in our enterprise version, we have security.
Sure.
Hopefully this stuff is not running on your edge, where it's a security issue. If it is, you probably need the enterprise version, which has SSL, TLS,
Joe, are we
things like
kind
that.
of towards the end here? Or?
Yeah, we're coming towards the end. So I just wanted to complete the exploration of the flight tracker demo. Again, so now this is the kind of information that someone says, I have no idea what's happening right now. Now, maybe I can go into our data swamp and pull up all the data from 10 years ago and determine on a daily basis how much CO2 these planes and the people who are living in the vicinity of an airport is experiencing. What's the effect of the CO2 on the environment in major metropolitan airports? What's the noise situation for the people who are living close to these airports? What they're experiencing, and then you might see some trend in the data, but you have no idea if it's currently happening and if the data is still relevant, right? Here you can get it live in this situation. You can make decisions. If some kind of, if the airport itself or the airline might be interested in this kind of information, the EPA might be interested in this kind of information, things like that. You might say, you know what? Also, what's interesting showing up in these data streams now is there's a data stream for drones. You can actually, so I'm getting the longitude and latitude of each of these aircrafts. That's how I know which airport they're in. So I'm creating a box of longitude and latitude around the specific airports of a certain radius. But yeah, you can actually track these airplanes and see where they are, and maybe drill down and see a map of where the actual airplane is. I don't know if you do a lot of traveling, you might use this flightaware.com. Yeah, they're using the same data set, by the way, and they're usually more accurate when you're sitting at the airport and they don't tell you your plane is delayed. FlightAware knows where your plane is. So, yeah.
You got a question back there, Joe?
I have a question. So, because you're doing machine learning, do I need a separate AI or your product comes with it?
Yeah, so,
It's pluggable.
well, no, that's a very good question. So that is actually a gap where we don't actually do the training of the machine learning algorithm. There's some other products that do that. Don't remember if I put those in my little picture somewhere. But training that algorithm, updating the algorithm, that's part of the whole process. So one of the things we allow you to do is that job that's running, you can actually update that job in real time. We have in the enterprise version, we allow you to basically just upload the new jar that has your pipeline job in it, and change the behavior of your analytics without taking down the system. But training a model or something like that, there are other tools for that. We don't actually train the model.
But it can be put into the system, right?
Yes. That's what we're doing with the Stanford natural language
There's another
processor.
question in the back.
Okay. Yeah, so model training. So we were talking about, so one of the things that happened during the big data popularity contest was that we created these data scientists, and they had a hard problem because now they had to create all this infrastructure, like wait for it to, they're not computer programmers, right, typically. So trying to find a separation between your data scientists and your actual application programmers was hard. Data scientists are not the best application programmers, so they may write jobs and things like that that may take down the infrastructure. Just getting the infrastructure up and running was a problem, so they weren't able to add value right away. So that kind of put a damper on the whole big data arena. So now you can create faster apps. The real data scientists are really the ones who are working on that Stanford natural language processor, the ML training, those kinds of things, the algorithms for calculating risk. So now you can say, all right, give that algorithm to your programmer. He builds the pipeline. He puts that into the pipeline code, and you can update. Every time you update that particular algorithm, you have a method or a way to just update the job itself without taking the system down. So now the division of work is more separated between your data scientists, your quants in the investment arena. Those guys, they're not programmers. They're like, I just want to build an analytical model, right? And you put it in there and scale it for me and make sure it works against a huge data set. I don't want to worry about having to build how many Java servers or whatever it might be to actually get that done. So yeah, you have a better separation of work.
About 2 minutes.
Now.
Yeah.
And again, adding value. You add value not only because you can do things faster in a small time. You can actually get going in terms of writing such difficult application in a shorter amount of time, and get it to scale as far as developer productivity. Yeah, and that's my little splee for today.
Thank you, Joe Sherwin. Joe will be here for one-on-one questions right after the raffle, so just stick around. Someone is going to win that. Before we do the raffle, Francis, one quick 2 words.
Thank you. So, hello everyone. This was very enjoyable and educational. My name is Francis Burwa from Layer East. I just wanted to give you a little bit of information about us and who we are. So Layer East is a co-working space right here in New York. We are actually accessible and available for anyone who is interested to potentially come and network with us. We provide access to events for our members such as this, and of course connections with other companies. So if you guys are interested, please feel free to talk to myself or Marianne and anyone else that you meet here when you come visit. We're always open. Thank you.
Thank you.
Yeah.
Can I ask you to just mix it all up? That's
I find a random Italian.
all right. Can I ask you to mix it up because you did a very good job? Can I ask you to look that way, all the way over, and then reach in and pull out a card? Well, no, go with that way. No, pull it out, pull it out. Take one. All right, read out what it says, the name. Jin Z. That's you. All right, you have won the Bose eyeglasses. So come on up and get your glasses. Joe is here for one-on-one questions. Where'd he go? Oh, right there. Joe is there for one-on-one questions. Feel free to come on up and ask him. Thank you all for coming.
Thanks, guys.